Okay, so where we left off in the section 1.2 sheet, so if you grab that and get it going, we talked about interval notation and we got through that, and now we are going to, again, this is review. If you had intermediate algebra here at Polk State, then you have seen this pretty much same thing, but it's super important because when we get to the second section of this class and the second unit of it, everything we do from here on out involves functions. So it's important to understand what they are. We're going to look at the structure of them and be able to work with them pretty quickly, because then when you move beyond to pre-calculus and calculus, it's all about functions. So your math life kind of becomes defined by this. So first thing we're going to define is what's called a relation. A relation is pretty simple to define. It's just a set of ordered pairs. And we know ordered pairs from our Cartesian plane. They're how we locate our points on the Cartesian plane. Okay, and so what this means, I'm just parenthetically going to write this. What this means is ordered pairs define a relationship, and that's why this is called a relation. So ordered pairs define a relationship. So in the examples that we've got, I've got 5 different ways to define the relationship that you're going to see in your problems and in your homework and on your test and in future classes. And so I'm just going to flip through real quick. The first 3 examples, the relationship's just going to be defined through giving you the sets of ordered pairs and listing. On the second page, you see that I've got a couple tables. We've got a couple mappings. These are all different ways to express the relationship. When we get to the third page, we've got graphs that express the relationship. And then the final thing we'll do on the last page is we will get to function and notation and actually having equations that define the relationship between our x's and our y's in our ordered pair. So we're going to come back. We're going to do things with all of these different relations that we have, but I'm going to flip the page. I got to define something else before we come back and do that. So at the top of the next page, what we're going to do now is define a function. A function is a specific type of relation. It's a specific type of relationship between my x's and y's. And so a function is a relation, meaning a set of ordered pairs. So a function is a relation in which each x corresponds to exactly one y value. So just repeating that while you're writing it, a function is a relation in which each x corresponds to exactly one y value. Another way to think about that, again, your brain might be rusty because we do this at the very beginning of intermediate algebra and then don't talk a whole lot more about it after that. We do it when we're talking about lines. Another way to think about it is a function is a relation in which each x occurs once. So each x value occurs one time. Okay, so what we're going to do is we're going to go back through on the bottom of the previous page, and we're going to look at the 3 relations that are defined by sets of ordered pairs, and we're going to see which ones are and are not functions. So I'm going to do the first example on the left. I've got -2, 3. I've got 0, -6, 3, 5, 7, -2. What would you say? Is that a function or not a function? It's a function. Why are you saying that? Each x occurs one time. And what that means is that x, this -2, has exactly one y value, and it's 3. This 0 has exactly one y value, it's -6. 3 has exactly 1, it's 5. And finally, 7 has exactly 1, that's -2. So you are right, great job. That is indeed a function. So I'm going to give you about 20, 25 seconds for exercise 5. Determine if relation B and relation C is or is not a function. So relation B, is relation B a function? Yes or no? No. What's the problem? Okay, 1. Notice the x value 1 corresponds to 2 y values. This corresponds to 2 and -4. So this is not a function. How about relation C? Function or not a function? Yes, the reason I put this example on there is even though a function has exactly 1 y value, it doesn't have to be different y values. Okay, in fact, halfway through the class, we'll talk about another specific kind of function. We'll get even a little more precise, and a function that has unique y values. Okay, that is a thing, and it has some special properties that we'll be able to use. But this is a function. Each x has 1 y value. Okay, 2 more terms. I'm sure you're expecting these. I'm sure you've seen and used these, but I'm just covering all the bases in case. So we've got the domain of a relation and the range of a relation. So drawing on your knowledge, your prior knowledge, anybody remember what the domain of a relation is? It's the set of x values. So the domain of a relation is the set of x values. Uh-oh, the purple pen's failing me. And so then by extension, the range is going to be what? Perfect, great job, the set of y values. Okay, again, I'm going to go back to the front page. I know that this is probably super simple, but again, I'm just trying to be thorough. I don't want any deficits that I've created here to rear their heads later. So in example 4, relation A, we determined it was a function. And so then what's the domain? I'm going to abbreviate DOM. What's the domain of this function? Yep. So I'm going to use a brace, and I'm going to write these numbers that you're telling me, -2, 0, 3, and 7. And I tend to put my my domain and my range in number order just because it's easier to read. And so then the range, which I will cleverly abbreviate RAN, is what? -6, -2, 3, and 5. Wonderful job. That's beautiful. Any questions, comments, or concerns about identifying these things? If you need anything from me, remember, just raise your hand. This is a class of 30 people, so I don't know if you're having an issue unless you tell me, and I love questions. Okay, so we're not going to do this for everyone, but I'm going to pick some. So go ahead for relation C. Go ahead and write down what the domain and the range is, please. Yes. When you're writing a list, when you have a bunch of individual values, it really does not matter the order. But remember, in interval notation, as I mentioned the last time, interval notation, it does matter the order. And we'll do some that we need to use interval notation in a little while. Okay, great question. Thank you. Okay, so for relation C, the domain, what did you write down for that? 2, 3, 7. Beautiful work. Thank you. And then finally, the range is just 4. When something's repeated, you only have to write it once. Okay, you don't have to write it multiple times. Okay, so flip the page. We're going to do the same couple things for the ones in the table. So here's what I would like you to do. And you're going to do both of the ones in the table. I would like you first for both example 5 and exercise 6, determine is it a function or not a function. Do that for both. And then for exercise 6, write down what the domain and the range is, please. So example 5, looking at that, is example 5 a function or not a function? It's a function. Why is it a function? Each x is listed once. Okay, so I'm only hearing a few voices. I hope that's just because you're so bored because this is such a review. Okay, so this is a function because none of the x values are repeated. Yes, excellent work. Okay, how about exercise 6? Is that a function or not a function? Why is it not a function? Yes, in fact, it fails twice. It only has to fail once, but the -3s are repeated and the 7s are repeated. So that means that those particular x values have more than one y value. That violates the definition of a function. Doesn't matter whether it's a function or not, we can define the domain and the range. So I will do that. The domain of this are what values? Beautiful, thank you for participating. And then the range of this is, yes. And again, I won't mark it wrong on the test if you write those in a different order. It's not super important, but it does stop me from getting cranky and getting a headache when you do put it in number order. So I appreciate your help. All right, so same thing, example 6 and exercise 7 down at the bottom. For both of those mappings, determine if they are a function or not a function. And then for the second one, identify the domain and the range, please. So this time, the relationship is defined by those arrows, the mapping from the x over to the y. So example 6, is example 6 a function or not a function? It's a function, and the way that I know that is each x gets exactly one y value, and I can see that because each x has exactly one arrow leaving it. Okay, exercise 7, is exercise 7 a function or not a function? Why? Which one violates it? Yeah, -2. -2 has 2 arrows leaving it. That means that it is related to 2 y values. And so the domain and the range, the domain are just the x's on the left, -2, 1, 6. The range are the y values on the right, 0 and 1. And there we go. Before I turn the page, anybody got a question, comment, or concern? Are we doing all right? I know this seems almost trivial probably, but again, understanding what a function is means everything when we get to chapter 2. Okay, so that's why I'm trying to just make sure to cover this super well. Okay, now you notice on these first 2 graphs, there's nothing there. So I don't know how to do points on the math program that I have. So here's what we're gonna do. We're gonna do this old school. So you're gonna label this point right here, -4, 2. Okay, and then we're gonna have 0 and -6. And then I'm not going to spend all day with lots and lots of points, so we'll just do 3 on this one, 5, 4. I'm also going to label the points on the graph that's just to the right, and then I'll pause and give everybody a chance to get caught up. So on that one, I'm going to do -3 and 5. I'm going to do -3 and -4. 0, 1, or excuse me, 1, 0, that's better. And then 7, 7, 3, and 7, -2. And like I said, I will pause for a second, give you a chance to write all those down. I don't want to get ahead of you. It's something, again, that's probably pretty relaxed. This one right here? Yeah. 7, 3. Okay, so here goes. We're going to answer the same questions here for example 7, exercise 8. I'll go first. Example 7, looking at those points, does that relation represent a function or not a function? It's a function. Again, each x has one y, and I can just go across the x-axis and say, oh, okay, there's only one y value there, and there's only one y value down there. So for sure, that is indeed a function. I'm going to give you 10 seconds for the next one, exercise 8. I want you to write down, is that a function or not a function? And what is it? Not a function. Everybody says that with enthusiasm. I appreciate that so much. Now, here's why I start with this. There's 2 reasons for these examples. First, we're going to notice as we notate the domain and the range, the difference between doing that when I have just 3 or 5 or some number of points labeled like this, and then notating the domain and the range when I have a continuous line that has no breaks in it. Okay, so that's going to be a really important distinction that I want to make sure that we hammer home. And then the second thing is I just want to use, I think you all had a pretty decent time of seeing which one's a function and not. And I want to just use that to say, in general, how can we determine if a graph is a function or not? So over here, this one that's not a function, you notice that -3 has 2 y values associated with it. So what we see is these 2 points, they are right on top of each other. And we use that fact to determine or to invent something called the vertical line test. What the vertical line test, apparently I'm having trouble speaking today. What the vertical line test says is if you pass a vertical line over a graph and it touches more than 1 point at a time, a vertical line, then it's not a function, because that means there's more than 1 y value. And so I just dotted this purple line to indicate what that means. This vertical line right here intersects 2 points on that graph, so it's not a function. So let me write that down in case you've not heard that before. If a vertical line touches a graph in more than 1 point, it is not a function. That's as opposed to the one that's on the left, example 7. If I took a vertical line, if I had a ruler, if I was actually a prepared instructor and had a ruler, I'll use this business card that's sitting here. If I pass this vertical line across it, notice it just hits the graph at 1 point at a time. So that's how I know, and I can make a very quick judgment on if something's a function. So the other thing, let's just one more time, domain and range. So example 7, I'm just going to real quick jot down what the domain and the range is. The domain is the set of x values, so that is -4, 0, and 5. Oops. And the range is the set of y values, so -6, 2, and 4. So notice, I had 3 distinct points. Okay, they're not connected by anything. So I at most have 3 x's and 3 y's in my domain and range. There could be less. Do the same thing for exercise 8, domain and range, and then we'll move on to the graphs that are right below and do the same sort of thing. So the domain of this one, I'm hoping what you wrote down is -3, 1, and 7. And then the range of this one, you wrote down -4, -2, 0, 3, and 5. Again, I've got individual points, so I list the x and the y values. Is that making sense? Okay. If that lacks clarity when we get to the next example, please let me know. This is one of the most common mistakes students make going into the first couple of units. Is the distinguishing between the notation when I have distinct points and I list my x and y values, and then something like example 8 where I have graphs. So remember, from whatever experience you have in graphs before, when we draw a graph, it represents all points, all values. Okay, it's supposed to determine that relationship. So example 8, when I perform the vertical line test, do I have a function or not a function right here? Not a function. It fails a lot. I'm just going to draw one particular vertical line just to illustrate. Notice this vertical line here hits the graph in 2 places. So that means that there is at least one x that has 2 y values associated with it. So this is not a function. Now the domain and the range. We're going to now draw back on the interval notation we talked about last time. And so the domain is my x values. So I'm going to look left and right. I can't list all the x values because there is an infinite number of x values. It would take a long time to write out an infinite number of values. Okay, so what I'm going to do is use interval notation. What's the lowest x value of this circle? What's the furthest left this graph goes? Okay, -5. I'm going to put a bracket there because it goes through that value. And then what's the highest x value? Okay, 5, and I'm going to put a bracket there. Great. The range. What's the lowest y value? -5, and the highest y value? And remember, what interval notation is telling me, it's not just saying the x value is -5 and 5. It's not a list. It's saying -5 to 5 and everything in between is also included. That's what this notation means. So we need to be precise in notation. I will be a little fussy on notation this class. When we write a set to indicate that I just have 3 x values, notice we use braces. We don't use parentheses for this. We don't use brackets for this. We use braces for a set. When I'm using interval notation, I use either brackets or parentheses for that. That's how I know the difference. Okay, so don't use braces on your interval notation. That's not what they mean. So please do exercise 9. Same thing, function or not a function, then define the domain and the range, please. All right, so here we go. Exercise 9, is a function or not a function? Not a function because it fails the vertical line test. I'm just going to pick one example. There's a whole bunch of them, but right here at this x value, when I draw a vertical line, notice it has 2 y values. So this is not a function. Is anyone having a problem distinguishing that? Okay, please let me know. Happy to keep rolling forward, but I don't want to leave anybody behind. Okay, so the domain, what's my lowest x value? -2. My biggest one is 6. I'm going to use brackets because it goes through those values. My range, what's my lowest y? -3 up to 1. And I'm going to use brackets because it goes through those. We still doing okay? All right, here's my next example right below, example 9. Now I'm going to give you a little caveat. And if you forget this on the test, that's okay. Sometimes I forget to mention it. The graphing utility I use on the website doesn't have arrows. So if you notice a graph goes to the edge of this, just assume that there's some arrows there. Okay. Now, if I forget to mention it on the test and you don't assume the arrows, I don't mark you off for it, but it makes a difference in our answer. So first thing, this thing, it's called a parabola. We'll learn that week after next. Is this a function or not a function? It's a function. Notice, I'm just going to draw a few examples of vertical lines. Notice every vertical line I draw goes ahead and goes through the graph in one place only. That's what makes this a function. Now my domain and my range. So my domain, we're looking left and right. How far left does this graph go? Yeah, forever. Okay, so that's what the arrow is telling me. That's why it's significant. And so the lower bound is negative infinity. How about the upper bound of the range? How far right is this going to go? Yeah, infinity. What do I always use at infinity? Yep, thank you very much. Appreciate that. And then the range. What's the lowest y value on this? -3. And I'm going to put a bracket there. And then what's the highest y value? Yeah, this jets off to infinity. Fantastic. And there it is. Please do the same thing for example 10, function or not a function, and then please define the domain and the range. All right, exercise 10, function or not a function? Okay, it's not a function. Here's my example. That x value that I just did the dotted line for goes through the graph in more than one place, so not a function. Again, as I said in the previous problem, we can assume arrows on the end because it goes over to the edge of the graph. And so now my domain, I'm looking left and right. How far left does this graph go? Negative infinity, yes. And how far right does this graph go? 5. And I'm going to put a parenthesis at the infinity because that's what I always do. And then a bracket at 5 because it goes through that value and includes it. And then the range, how far down and how far up does this go? Yes. Is everyone tracking with me? Am I doing okay? Am I going too fast? Am I not explaining things thoroughly? I just need your inputs. Just want to make sure. Are we doing okay before I turn the page? Yes, ma'am. Vertical lines always go up and down, but you can put them anywhere you want. Yes, yes, for sure. That's just a representative example, not exhaustive. Okay, you could have drawn and said, oh, it fails over here, which it does. This graph right here, this parabola that's on its side, fails infinitely to be a function. Yeah, no problem. Great question. All right, last page of this. Here we go. Now these next two graphs, they do have a starting and a stopping point. That's intentional. Okay, so there's no arrows on the end of these ones. So what I would like you to do in example 10, function or not a function, domain and range. Let's see. All right, so on this graph right here, this relation, is it a function or not a function? It's a function. The vertical line test, if you pass a vertical line, it's always going to hit one place. Great, so that's a function. I told you not to assume any arrows on this one, so my domain, how far left? What's the lowest x value? -2. I will never try to trick you. It's never going to be like -2.1. If it looks like -2, it is -2. And then what's the highest x value on this one? 4. And then the range. What's the lowest y value? 1. And what's the highest y value? 9. Great. I just have a bunch of these because reading graphs is a preeminent skill in this class. Okay, so I'm just trying to hit this as hard as I can so that you're really comfortable looking at graphs and writing down intervals as we go through this. Exercise 11, same thing, please. So exercise 11, function or not a function? It's function for the same reason example 10 was. Very good. And then my domain, it looks to me like the lowest x value is -3 and the largest x value is 2. And then the range, it looks like the lowest y value is -2 and the largest y value is 3. All right, that's a lot of domain and range, function, not a function. We good? We're doing okay? Yes. No. What's wrong?
I forget the point. I don't know why maybe I'm looking at it wrong. I think it's 419.
Okay, so I'm looking at, for my domain, I look left and right. So how far left? What's the leftmost point? Well, it's this point right here. Okay, I'm gonna make a little dot. What are the coordinates of that point right there? That point is -2, -2 and 1. Okay, so that tells me that the lowest x value is -2. That's why that's there. Now I go to the right. What's the furthest to the right this graph goes? Well, it's this point right here. And so the coordinates of that point are 4 and 7. And so that's why I got this x value of 4. That's the largest x value. Then the same thing with the y values. The lowest y value is again found at this point, which is -2, 1. So that's why this is a 1. And then the highest y value happens to be at the top of this curve right here, approximately right here. And that is at the y value 9. Okay, and that's where that came from. And so the same thing over here. Okay. Great question. If you're not clear, always ask for clarification. Okay, one final thing from this section, and then we are done with our introduction to functions. We're going to talk a little bit about function values. So I'm going to start with example 11. I'm going to work this one with you. So in example 11, we saw that in example 4 on page 1, we determined that relation was a function. What we're going to do is we're going to define function values. So function notation works like this. Again, you've most likely seen this, but just in case you haven't, function notation looks like this. F of x is equal to y. This is another way to write your y values. It's just a fancy way. And so the x is always the thing in the parentheses. It's the input. In math terms, you don't have to know this. This is just bonus knowledge to share with friends and family members. That's the dependent variable. Oh, I'm sorry, I got it wrong. So don't share that with friends and family members. That's the independent variable because that's the one you pick. And then the y, the output, is the dependent. It depends on what you picked for the x. So what I am asking is, okay, according to the relationship that was defined for us, if I tell you that the x is 3, what's the y value? Well, I'm going to go back to page 1. Okay, and if you're watching on the video, I'm sorry for all the flipping. So I'm looking at this. Which point interests me if I'm looking at the function value of 3? Yes, this is the point right here with the x value 3 right there. So what is the corresponding y value? 5. Fantastic. So I'm going to go back to the last page and I'm going to say, okay, the function value at 3 is 5. Let's do it again. Practice makes perfect. What's the function value at 7? Well, again, I'm going to go back to page 1 and I'm going to look at my ordered pairs. Which one involves an x value of 7? Yep, this last one right here. And the output, the y value, is -2. Everybody tracking with this? I can't see your faces because I'm not wearing my glasses. Okay, so if you have a confused expression on your face, all I can see is a blob right now. So I can't wear my glasses and write, otherwise I can't see the page. It's really weird to get old, everybody. You're going to love it. So if you need anything, you have to tell me, okay? All right, last one, function value at 11. So let's go back to the front page. The function value at 11. Which ordered pair has an x value of 11? None of them. So what we say is this relation is not defined. That won't happen all the time, but I just wanted to cover it in my example. So what I would like you to do, exercise 12 says, we determined example 5 was a function. Find these corresponding function values, please. All right, example 5 is the table on page 2. And so I want to know what the function value at -6 is. So I go to the table on page 2. And what is the corresponding value to the x of -6? Okay, it's right here. It's the y value of 2. So I will write that down. And then what's the corresponding y value for the x value of 11? Okay, again, 2, and that's fine. Doesn't matter that it's the same. Remember, y values can repeat in functions. It's x values that don't repeat. So let's see. Just for time's sake, I think we're going to skip exercise 13. It's not super difficult. I'll write down the answers. Go to exercise 14, and for the function in example 9, which is a graph, find the function value at 6, please. So I wrote down the answers for exercise 13 if you want to jot those down and double check later when you're doing your homework. Exercise 14, again, I wanted to hit this one because reading graphs is super important. I want to know what's the function value at the x value 6. So I come back over here to example 9, and my x value 6, 1, 2, 3, 4, 5, 6 is right here. And what's the y value at this x value? It looks like -1. Okay, so it is -1. I'm not going to ever try to trick you and say, oh, it was really -0.95 or something like that. That would be terrible. So the function value at -6 is -1. All right, finally, we're almost done with functions. We each have one more example to go. And this last one is what happens when my function, I'm not given a graph, I'm not given ordered pairs, I'm given a equation to define the relationship. So here I've got f of x is equal to 5 minus 2x. I'm asked to find the function value at 4. What am I going to do with the 4 here? Where am I going to place it? You're going to plug it in for x. Yes, again, I'm pretty sure most, if not all of you have seen this before. And if you haven't, we're just figuring out the value. So I've got 5 minus 2, and what I like to do is wherever I see my x, I like to put a parenthesis, and that's what I'm going to fill in. So I'm going to put a 4 right in that parenthesis. Order of operations from middle school, you do your multiplication first, so that's 5 minus 8, and then 5 minus 8 is -3. We can do the same thing for the function value at -5. So again, my function is 5 minus 2x. So that's 5 minus 2, and I've got some parentheses there. And now I'm going to put a -5 in the parentheses. Once again, order of operations from middle school, that's 5, and then -2 times -5 is plus 10. And that turns out to be 15. All right, I'm going to give you about 45 seconds to do the first part of the last problem. Find the function value of g at 2. Please find the value of g at 2. All right, so we're going to go through this. We're going to see if you made any mistakes. I'm going to give about another 45 seconds to do the last one. So my function g is defined to be 3 times the x value minus 2 times the x value squared. So again, what I like to do, the habit I always have is before I even plug any numbers in, I like to say this is 3 times my x value. I'll put a parenthesis minus 2 times my x value squared. And so this time I'm plugging in a 2. So I'll put a 2 here and a 2 here. Order of operation says we always do those exponents first. So you can do more than one thing first, but for this problem, I'll take it one step at a time. So I have minus 2 times 2 squared. 2 times 2 is 4. Don't multiply these 2's first. That violates the order of operations. Okay, so if you have 4 squared here, that's wrong. So now my multiplication, 3 times 2 is 6. Negative 2 times 4 is negative 8. And this ends up being negative 2. All right, last problem for the function section. Find the value of g at negative 3. Be real careful of that sign. Okay, so once again, my function is 3 times x. So I put a parenthesis where the x is, minus 2 times x squared. So minus 2 and parentheses squared. This time I'm plugging in a negative 3. Okay, the negative goes with the 3. So when I square it, this is the most common mistake. Okay, I'm gonna put a problem just like this on the test with a negative because I want to make sure that you've got your details in order. And so spoilers, I know it stinks when I tell you what's on the test. 3 times negative 3 is negative 9. The negative 3 squared, negative 3 times negative 3 is positive 9. And then what we end up with here is negative 9 minus 18, which is negative 27. There is my output when I put in a negative 3.